This project is the first part of the CHUMP build, which stands for Cheap, Homemade, Understandable, Minimal Processor. The circuit is powered by TTL or transistor logic chips, allowing the function of the 4-bit breadboard processor. The first part of this project uses three 555 timers to deliver a square wave signal to the SN74LS161. The first 555 timer is attached to an astable circuit that emits a square wave signal with a variable frequency that can be controlled through a potentiometer. The second 555 uses a monostable circuit with a button debounce, allowing you to control the square wave with a button attached to a pull-up resistor. The third 555 is a bistable circuit with an LED that illuminates when the slide switch is connected to the astable circuit and turns off when the slide switch is turned towards the monostable circuit. The slide switch can change between automatic counting using the astable circuit or manual counting using the monostable circuit and uses combinational logic to do so. The halt line is attached to a slide switch, so only when the slide switch is given a low signal, the circuit progresses. When it is given a high signal, the count is frozen. The purpose of the clock signal is to advance the line of code in CHUMP by one with each square wave signal. The astable circuit allows CHUMP to cycle through lines of code automatically at the frequency desired depending on the position of the potentiometer. The manual monostable circuit allows the user to manually change the line of code that CHUMP is reading. This is done using combinational logic with the SN74LS04 inverter IC and the SN74LS08 AND gate and a SN74LS 32 OR gate IC. These three chips use combinational logic to allow the user to select one overall output signal. The second part of this build is the program counter circuit. The circuit uses an SN74LS00 NAND gate IC, 3 buttons, and an SN74LS161 4-bit counter IC. The line of code that the processor is on can be shown in binary on its output pins, which is displayed using the 4 LEDs. The line can be reset to 0 using the clear button attached to pin 1 using a pull-up resistor. The 4 LEDs can also be flipped through manually using 4 switches and 2 buttons attached to the NAND IC with pull-down resistors. When the 2 buttons are pressed together, the LEDs switch from counting in binary to illuminating depending on the position of the 4-dip switches wired with 1K pull-downs. The final part of the project is the CHUMP code. The 9-line program created for this build counts down from 8 to 0 and resets back to 8 when the count reaches 0. This is done using 2 main parts, the first of which reads the value in the address 0 and adds 8 to it, switching from an initial value of 0 to a value of 8. The second part of the program repeats on loop, reading the value of the address 0 and subtracting 2 from it until the value reaches 0. When the value reaches 0, an if-0 statement sends the code back to the first part of the program, adding 8 to the count again and restarting the process. The code is an infinite loop that will repeat adding 8 to the count when it is 0 and subtracting 2 from the count until it reaches 0.